Hello everyone. In this video we're going to continue our work with linear equations and their graphs, and in particular we're going to learn how to use slope to graph equations of lines and linear models. Okay, so for this example we're going to sketch the line that has slope negative 2/5 and y-intercept 0, 3. So basically we're going to go ahead and start at the point that we do have for this graph, which is basically the y-intercept 0, 3. Remember, the y-intercept is the point of intersection of the line and the y-axis, so it's certainly a point on the line, right? So now the slope is given as negative 2/5, right? Notice that you can think of that as negative 2 over positive 5, or you can think of it as positive 2 over negative 5. Both those interpretations would be correct. If you are going to view it in this manner, that means starting at a point such as 0, 3, you can go down 2 and then right 5 to obtain another point. So from this point 0, 3, we will go down 2 units and then we'll go right 5 units. So 1, 2, 3, 4, 5. So right there we'll place a dot. So there's another point on our graph, right? And all we have to do is draw the line that goes through those 2 points. So we just place our ruler and we draw the line. Okay, so that would be the sketch of the line that goes through 0, 3 and has a slope of negative 2/5. So we went from starting at that point, which was 0, 3, we went down 2 units and then to the right 5 units, right? So in case you're going to use technology like Math Excel to enter that, you'll pick 0, 3. Now remember, we went down 2 units, right? So the 3 becomes 1, right? And we went to the right 5 units, so you need to add 5 to the 0 and you get 5, 1. So the 2 points you would use in your sketch would be 0, 3 and 5, 1. Now you may wonder, you said this is okay too, right? So you may wonder and you may tell me, you said you could use this too. Of course you could. So instead of going down 2 and then right 5, you could have gone up 2 units and then left 1, 2, 3, 4, 5 units, and you would have come to another point on the line. It would just be a different point, right? Yeah, my graph, my line is not perfect. So once you do this on a system like Math Excel, it'll work out perfectly. So you would be able to do that motion as well. So either go down to 5 to the right, or you can go up 2 units and then 5 units to the left. It's just that you will end up at a different point on the line. But remember, all you need is 2 points to draw a line anyway. So okay, I messed this up. You know the point I'm making, right? Okay, I cleaned that up, so something like there. Okay, so it doesn't matter. You could use these 2 points to draw your line, or you could use these 2 points to graph your line, and you get the same graph. You're still going to be on the same line. Okay, so you can play with signs like that, and there's no problem with that. Both will work. Okay, so we've already mentioned the fact that the slope-intercept form of the equation of a line is the following form that we're familiar with. Let me show that. y equals mx plus b. Now, so far you've accepted that on faith, but it's very easy to derive that formula, and it's a great kind of practice to be able to do so. So let me go ahead and put up a grid. And once we define the equation of slope, which as you know is m equals the change in y, so y2 minus y1 over the change in x, so x2 minus x1, then deriving this slope-intercept form of the equation of a line becomes a very simple matter because all we have to do is go ahead and label this point, for example, as x1, y1. And we'll consider this point to represent x2, y2, right? So now we can basically find the slope using the formula. So y2 is y, y1 is b. So we get y minus b over x2 is x itself, and x1 is 0. This is just again, just a general line. That's a general point on that line, and all we know about this ordered pair is that it is on this line, and 0b is of course the point of intersection of the line with the y-axis, therefore it's the y-intercept. So now notice we end up with, I can actually write this as a proportion in this way. And of course, you know that anytime we see a proportion, we can cross multiply, right, in this manner. So we end up with y minus b times 1, which is just y minus b, equals mx. And now all we have to do is add b to both sides or move b to the other side, and we end up with the form of interest. So it's no, magic where the slope-intercept form comes from. It simply follows the definition of slope itself. So clearly, when you look at this form, m is going to be the slope of the line, and b is the y coordinate of the y-intercept. We don't want to just say the y-intercept, because remember, the y-intercept is the ordered pair 0b. So we want to be very specific and precise, so we'll say b is the y coordinate of the y-intercept. So just to summarize, for a linear equation of the form y equals mx plus b, the slope of the line is m, and the y-intercept is the ordered pair 0b. And we say that this equation is in slope-intercept form. When you understand the slope-intercept form, then it becomes possible to graph a line without actually even making a table of values, by simply looking at this form. And this is why this is such an important form, the slope-intercept form, because it has all the information in it, contained in it, you need in order to be able to graph the line. So let's bring up a grid. Okay, so looking at this equation, we know that negative 3/4 is going to be the slope, and the ordered pair 0, 4 will be the y-intercept. So let's make a note of that. So the y-intercept equals 0, 4, and m equals negative 3/4. And remember, you can see that as negative 3 over positive 4, or positive 3 over negative 4. If you interpreted it this way, then starting at this point, that's a great starting point because it's one of the points on the line, so as good as any other point to start with. Then you can go down 3, right 4 to get another point, or you can use this interpretation and go up 3, left 4 to get another point. Either way, you'll get your second point that you need to graph the equation. So let's go ahead and start at 0, 4. So there we are. There's one of our points. And for the other point, let's go ahead and use the first interpretation. We're going to go down 3. So we go down 1, 2, 3, and then right 4. So 1, 2, 3, 4. So we're going to go ahead and put a dot right there. There are the 2 points that we're going to use to graph this line. Now we're just going to draw the line to graph, and that goes through them to graph the line. All right. So I just got rid of the whole thing. I didn't want to do that, but let me try it again. Okay. All right. So, and of course, remember, there are going to be arrows on both ends that keeps going forever, right? On both ends. And we just graphed this line without even making a table of values, just by understanding and interpreting the slope-intercept form. Could we have used the table? Of course we could have, right? For example, we could let x be 0. That wipes out this term, becomes 0 plus 4. So 0, 4, which we already knew, right? There's 1 point. Then we can let x be any other point. So a clever point would be 4, so that we don't end up with a fraction. So if I use x equals 4, I get y equals negative 3/4. So this is if x equals 4, that implies y equals negative 3/4 times 4 plus 4. Here, these will cancel out, so you get negative 3 plus 4, which is 1. So, and there's the other point. So we could have done it by setting up a table by substituting values as well. But we can simply just look at the equation and graph it without having to go through the process of creating a table. Of course, when you try to graph this on, say, my MATLAB or Math Excel, you are going to need to know what that point is. We already know this one is 0, 4. And remember, to get to this other point, we went down 3. So subtract 3 from the 4, we get what? We get 1. And we went right 4, so add 4 to the x value, which is 0, and you end up with 4, 1. Okay? So it all makes sense. Do notice we could have also taken this route. Starting at 0, 4, we could have gone up 3. So 1, 2, 3, and then left 4. So 1, 2, 3, 4, and we would have ended up at this point on the line. And remember, for that one, what is that point? Well, we went up 3, so add 3 to the y value, that becomes 7. And we went left 4, so subtract 4 from the x value 0, and you get negative 4, 7. So you could have used the y-intercept and this point as well to graph the line. Okay, so sometimes we're asked to find an equation of a line from its graph. And of course, if we can locate the y-intercept and find out how to get from that point to any other point on the graph, we should be able to get our equation, right? So here in this situation, we notice that the y-intercept, which is the place where this line crosses the y-axis, is right there. So first we need to know how many units are demarcated by each mark here. And notice each tick mark is 1 unit, right? So that means that's -1, and therefore the ordered pair is 0, -1. So our B would be -1, right? Now for the slope, what we'll do is we'll start at that y-intercept and get to some other point such as that point. We want to pick a grid point whenever possible, right? Otherwise, we have to just approximate or estimate. So notice that from here, I can go down 2, and then 1, 2, 3 to the right. So right 3, right? So what is the slope? Remember, down 2 indicates a -2, and right 3 indicates a +3, right? Of course, we always want to write the slope in a simple fashion once we want to put it into an equation. So we'll just write it as -2/3. So now we know that y equals mx plus b. We're going to substitute -2/3 for m, and we'll put plus -1. But see, you can put it in a manner that looks nicer than that, right? And that's what we'll do. For our final answer, we'll just put -2/3 x. Remember, positive times negative is negative, so we get -1. Remember, there's an invisible 1 right there. So this is actually a multiplication. When you multiply it out, you get -1. So that's where the -1 comes from, okay? So this would be the equation of the line that we see in this image. Okay, so let's go ahead and look at an application. Here's graphing a models line. The percentage of U.S. food sales that are organic products are shown in the table for various years. So in 2000, 1.2%, in 2002, 1.6%, in 2004, 2.2%, etc. So we noticed an upward trend, right? So as we move through the years, the percentage of organic foods in the market are growing. All right, so if we let P be the percentage of U.S. food sales that are organic produced at T years since 2000, a reasonable model is given by this equation right here. Graph the model, predict when 6.2% of the food sales will be organic products. So we know that the p-intercept is at 0, 1.1, right? And the slope is 0.3, right? So I brought the equation here for you to remember. Notice the slope is right there, 0.3. And the y-intercept, of course, is going to be 0, 1.1. So we can write 0.3 as 0.3 over 1. And notice if we clear the decimal by multiplying by 10 over 10, we just get 3 over 10, which is easier to deal with. So from there, right, you can go up 3 units and then write 10 units, right? And you'll get another point. So when you go up 3 units, you're going to add 3 to 1.1. That's where you get the 4.1. You go right 10 units, right? And that's going to be 0 plus 10, so you get 10. Notice it's not drawn to scale, right? The grid on the horizontal side is going to be 2 units per tick mark, whereas the vertical grid is only 1 unit per tick mark. Keep that in mind as you do these graphs. So if we're going to estimate when the percentage will be 6.2%, we notice that 6.2 is right around there. So from there, we draw a straight line, horizontal line, till we hit the line. And from there, we drop a perpendicular straight to the x-axis, right? So we notice that falls right between 16 and 18, so that corresponds to 17. Now remember, the t here is not the year, but it's the number of years since 2000, right? So if it lands on 17, we're going to take 2000 and add 17 to it, and we get what? We get 2017. For our last example, we're going to go ahead and analyze a model and make an estimate. Worldwide jewelry sales are shown in the table in the next slide for various years. Let S be the annual jewelry sales in billions of dollars at T years since 2000. And a model of the situation can be given by this equation right here. Use a TI-84 to draw a scatter plot and the model in the same viewing window. Check whether the line comes close to the data points. What is the slope of the model? What does it mean in this situation? We also want to find the rate of change in sales from 1 year in the table to the next to the next one listed, and compare the rates of change with the results that we found in problem 2. And then also find the S-intercept, interpret what it means, and estimate the sales for 2013. The problem is asking us to use a TI-84, which is rather older technology, but it's still a great tool to have access to. And we will do this one on the TI-84 as instructed, because it's good to see the capabilities of this calculator anyway. So basically what we're going to do is we're going to click on the stat function to create a list. And as you will see, this is nowhere as user-friendly as applications like StatCrunch, but it is very powerful. So here we're going to enter our list, and remember here we're going to put in not the year but the number of years since 2000 as instructed. That's what T will be, right? So for the first value of T we're going to put 9, and then 10, 11, 12, 13, and that's all there is for our first list. Then we go into our second list and we're going to put 202. After each enter you hit enter, so 214, 246, 278, 300. TI used to be the go-to calculator, but they never proceeded with like coming up with any kind of open source version or anything like that. So they kind of fell out of popularity a bit because students get access to applications like StatCrunch, etc. Or you've noticed Hewitt Packard puts out a very, very advanced and nice calculator for free. So competition has been rough, and but they still do quite well with physical sales. They're just not doing very well with the software version as far as some of the classes that at least I know about are concerned. This is not a statement about national state of TI or anything like that. It's still a great machine and a trendsetter, to be sure. So once you have added your lists, you're going to go ahead and exit out of that. They're going to be saved. They're going to be there. So we can either hit second mode, which quits that screen. And now we're going to use what's called the stat plot feature. So for that, we're going to choose the first plot and we're going to turn it on. Notice it's off right now, so we're going to turn it on. And for the type of a graph that we're doing, we're going to be, notice these are box plot. This is a box plot. This is a box plot with outliers, etc. But the one we're doing is just a basic stat plot, which will be the very first option. So we go ahead and enter. Notice that the lists are already there for us. It's going to use the first list as the explanatory variable and the second list L2 as the response variable, and we're pretty much ready to go ahead and graph. So let me exit out of that. So now we're going to just push graph, and of course we see nothing, because if you click on window you'll see this is just going from -10 to 10 with a scale of 1, and the same on the y-axis. So all these values are going to be way outside of this range, right? So at least for the y. For the x's we're okay because they're going from like 9 to 13, right? So what we're going to do is actually use a clever feature on this, which is zoom. We click on zoom and then we go down to zoom stat. And now you can see the scatter plot very nicely. Now we were asked to graph the line in the same window. So we're going to be graphing this, but remember, in the TI-84, everything needs to be in the form of y and x. So here we're going to use y equals 26x minus 38. So now we have to click on y equals, and now we're going to use that 26. We can use this for x minus 38. Now if we hit graph again, you'll see it'll plot the line right there for us. And as we can see, that is in fact a very good best fit line for this scatter plot. Of course, if you have no access to the TI-84, not to worry, you can go ahead and do this using any of the calculators we've been looking at, such as ClassCalc or Desmos, etc. Okay, so let's go ahead and actually look at that on ClassCalc now. So in ClassCalc, we're just going to hit Add Table, and we'll enter the values that we had in the other table. So let me take a minute to do that. Okay, so here are values just like we put into the TI-84, and of course they won't show up again because of this standard window being too small. We're going to go ahead and push zoom fit, and that'll bring it into focus. So if we make it even a little bit smaller, it'll show us right there. And then if we go ahead and graph the line, which if you recall was, let's take a look at it again, y equals 26x minus 38. Okay, and we can see that definitely the line comes very close to the scatter plot. So next they wanted to know what is the slope of the model. Of course, we know the slope is going to just be 26. Remember, this is exactly in the form of y equals mx plus b, so this number here is playing the role of m. Okay. All right, next we were going to find the rate of change of sales from one year to the next, right? So we'll have to start here from 2009 to 2010. Remember, you're going to subtract those two, so 214 minus 202, and that'll give us 12. And here from 2010 to 2011, you're going to go 246 minus 214. The rate of change was 32. Then 2011 to 2012 right here, and you're going to subtract 246 from 278. We get 32. And finally, from 2012 to 2013, the rate of change was 300 minus 278, which is 22. So how do they compare to what the model is giving us? Well, this one is a little bit off, right? But notice these come within a reasonable range of 26 billion per year. So that's how the model is doing. So what is the s-intercept of this model? Remember, that's going to be the b, so therefore 0, negative 38 will be the s-intercept. So what does that mean? Basically, it means in the 0th year, that means the beginning of the experiment, so in 2000, basically, the sales were negative $38 billion, right? So this is actually a model breakdown, right? Because sales obviously cannot be negative, right? You either sell or you don't. The worst case scenario is you don't sell anything, right? In which case the sales would be 0. For the fifth and the last part, we're going to estimate the sales in 2013 using the model. Of course, that means all we have to do is in the model replace t with 13, because in 2013 the value of 2 would be 2013 minus 2000, which is 13, and we end up with 300. So according to the model, the worldwide jewelry sales were around 300 billion in 2013. um, and we see this result is pretty much identical. Let's go back to our table. As you can see, the actual sales in 2013 were also 300. So the model did really well for that year, actually. So very close to the model. So what that means is, if you look at the model, not surprisingly, it means that point actually was on the model itself. That's why we got an exact hit. That's why the predicted amount according to the model was exactly the same as the actual sales, because this dot represents the actual sales level for 2013. All right, so that kind of does it for our graphing and kind of interpreting some of this linear data. So what we're going to do now is look at a few problems from what you may encounter on homework, and that should do it for us today. All right, so here's a basic problem where we're giving a slope and a y-intercept and asked to graph the line. So remember, we're going to start at the y-intercept. So let's go ahead and choose the line tool. The line with the y-intercept is 0, 2, so we'll go ahead and click there. And now the slope is 3/4, so we know what that means. That means we're going to, if we write it out, m equals 3/4. That means you can look at it as +3 or over +4. So we're going to go up 3, right 4 from the y-intercept to get ourselves another point. Notice we could also go down 3, left 4, like that. So we can always write +3/4 as -3 over 3 -4 as well. So down 3, left 4. So let's go back to our line now. So we're going from this point, we're going to go up 3. So 1, 2, 3, and we're going to go right 4. So 1, 2, 3, 4, right there. Okay, and we're going to finish our graph that way. Notice we could have also, starting at 0, 2, we could have also gone down 3. In other words, we could have done this. We could have also gone down 3 and then left 1, 2, 3, 4. See, we would have ended up on this other point, which would be another point on the line. So perfectly another good candidate for helping us graph the line. So this one looks a little bit different, but it works the same way. Notice the y-intercept is 0, 0, so we're going to start there. Actually, let me bring up the line tool. So 0, 0. Then we're going to listen to the slope, right? In this case, notice that the slope is -2/5, which can be written as -2 over +5, or as +2 over -5. So to get to another point on our graph, we can either go listen to this one, go down 2, right 5, or we could listen to this one and go up 2, left 5. Okay, so starting at 0, 0, we're going to go down 2 and then to the right 1, 2, 3, 4, 5 units right there. Okay, notice that we could have gone up 2 and then left 1, 2, 3, 4, 5 units, and we would have ended up at that point. So that would have been perfectly fine too. Okay, so that's how you handle those. So here, notice we're going to start at the y-intercept 0, 6. As always, try to do this on your own first, then come back to the video. That's what the pause feature is for, right? and the slope is -4. So like so. Remember, there are two ways you can write that: -4 over +1, or you can write it as +4 over -1. So to listen to that, starting at the y-intercept, you would go down 4, right 1, or if you listen to that interpretation of the slope, you would go up 4, left 1 to get to another point on the line. So let's have a look. Let's listen to this interpretation this time, okay? Just for variety. So this time we're going to go, notice first of all, each tick mark is 1 unit, right? So we're going to go 1, 2, 3, 4, and then left 1, just 1, and click. And then we can check our answer, and we're good to go. So remember, it makes no difference which one of those you follow. You'll get to another point, one other point on the line. Of course, one point you already know, and that's the y-intercept. So how would you handle one like this, where the slope is 0? Well, here they give us 1 point on the line, right? And that's 2, -5. When they say the slope is 0, that's another way of saying this line is what? Think about it for a second. This implies the line is, if you said horizontal, I agree with you, okay? So basically, to graph it, all we gotta do is, we're gonna go ahead and start the line tool, and then we're going to go to 2, -5. That's going to be our first line, first point. And then we just need to draw a horizontal line, right? So just pick any other point at that same elevation, right? Like that one. Makes no difference. And then you should be good to go, okay? So because the slope is 0, we knew it's horizontal. Okay, so here's another one. And for this one, you're going to be doing this yourself. I'll just give you a hint. What does it mean for the slope to be undefined? Think about that, and that's the hint. All right, that means the line is, I'm waiting for you to say it. Okay, I think I heard you say vertical. I agree. Okay, so remember, that's going to be a vertical line. So we're going to graph this using the slope and the y-intercept, and this confuses people at first sometimes because you're going, wait, what's the y-intercept? Remember, you can always put a +0, right? So remember, these equations that look like this and they have no b, apparently they actually do. It's just that b is what? Remember, you can always write them as y equals mx plus 0, right? So these equations where the b is missing but the x term and the y term are there, they always go through the origin. Why? Because think about it. This means the y-intercept is what? Is 0, 0, right? So you're going to start there, then you're going to listen to the slope, which tells you what to do to get another point. And remember, you can go down 5, right 7, or you can go up 5, left 7, whichever you like more. So here we will go ahead and start our line tool. And remember, our first point is going to be the origin itself, 0, 0. These lines go through the origin, and then we're going to go, well, here I could go down or up. Let me do this one. I'll go up 5. So 1, 2, 3, 4, 5. And then left 7. So that's 1, 2, 3, 4, 5, 6, 7. There's my point. There's our line. Okay, just like that. Here you're going to determine the slope and the y-intercept and then just graph the equation by hand. So the slope, of course, is the coefficient of the x term, right? So what would it be? -1. Y-intercept, of course, is going to be the ordered pair starting with 0, and that's going to be the y coordinate right there, and then you graph it. So you can go ahead and start at 0, 4, which is the y-intercept, and then you go, the slope is -1, so you can go down 1, right 1, or up 1, left 1, whichever you like. So here they went down 1, right 1, and there's your graph. So here's a really good exercise to help you make sure that you understand slope and the y value of the y-intercept very clearly, right? So look at this line right here. What kind of slope do you have? Notice these are the choices, right? You can see this one is a falling line, right? So the slope is negative. And B, which is the y coordinate of the y-intercept, notice this is going through the origin, so it's going through 0, 0, right? So what's B? 0, like that. Okay, so the fun of this is for you to do this. I'm going to let you finish that, but that's how you think about it. Okay, so now we're going to work backwards. We're given the slope and the y-intercept, and we just want to write the equation. So remember that to write the equation, all you need to know is remember x, the ordered pair xy is just a general point on the line. So those two are not going to change. The y and x are going to stay. All you need to do to get a unique line, you need to determine m and b. If you know m and you know b, you're ready to write the equation. And of course, notice they're giving you m, and since the x coordinate here is 0, that means this must be what? B. Remember, this y value is b only if the x coordinate is 0. If they give you another point, that's not going to be the y-intercept. We'll find out how to deal with those later. So now we're ready. So we have m equals -7/5. So you just get -7/5 x plus b. What's b? 3. So there is your equation. Okay? That's all there is to those. For this one, you're going to write the equation just from the graph, right? Again, as long as you keep in mind this simple fact that to get the equation of the line, you need what? You need m and b. If you understand that, you understood lines, okay? So notice we can start with b because it's easier. That point right there, what is it? Well, that's 0, -5, right? So that means this must be what? B. Then you can get the slope by just looking at how you can get from this point to that point. Notice you would have to go up 1, 2, 3, and right 1, 2. So what is the slope? The slope is up 3, +3 over 2. So right 2. So +3/2. Now you're ready to write the equation, right? So y equals what? Well, let's start with the general form of it, mx plus b, right? So now all you have to do is for m, use 3/2, and for b, use -5. Except you don't want to type it in like that because that's not the simplest form. The simplest form is for you to go ahead and multiply those two out and just write y equals 3/2 x minus 5. Just like that. This is a little different. All you're doing here is you're going to find the x value when y is -1 on this line. So basically you start at y equals -1, see, y equals -1, and you go straight across horizontally till you hit the line, right? So what x value is associated with that? Notice that would be x equals -2. That's it. So all you have to do is type in that -2 and you'll be good to go. Okay, simple, right? As I said, the rest of the term will be very much algebraic. So make sure that when you're doing your tests, you show anything that requires work. Some of these are simple, they may not, but we will be doing more algebraic stuff where work is needed. So make sure you show those on your answer sheets when you take your tests. Okay, so here we have we're letting n be the number in thousands of employees at a company at T years since 2010 for the period 2010 to 2014, and a reasonable model for that number of employees is given right here. So first we want to graph it by hand. Here, I mean, you obviously aren't actually literally going to do it by hand, but you need to understand what each one means, right? So notice that the slope here is -29 and the y-intercept is 0.589. So of course it would be easy to do it by hand. You just start at the y-intercept and then you go 29 down and 1 to the right. But let's go ahead and have technology do that for us. So we have y equals -29x plus 589. All right. So it's obviously not going to show up until we zoom fit it, right? So let's go ahead and do so. This ClassCalc does have the zoom fit for some features. I don't see it for this one right here, but if we just start scrolling using a mouse, we can see it'll come into view, so we can see what it looks like. Now, if you want to match this with the one on the test, you have to make sure you're using a similar kind of scale. So let's go back. Notice here on the horizontal axes, they're going from 0 to 10. Vertically, they're going from 0 to 10,000 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each unit here, each tick mark is representing 100 points, right? So you can do that, say in ClassCalc, by specifying that. So remember, for horizontally, we're going from 0 to 10. So we're going to, my recommendation, go a little bit to the left of 0, like say -2, and go a little bit to the right of 10 as well. So say 12, okay? Vertically, we're going to go from, say, -100, say, to 10,100, okay? Right. So 10,000. I'm sorry, 1,000. I went too far. I meant, say, 1,000, say 10, like there. Okay. So if you make it a little bit smaller, we can see the graph quite nicely. And now when you go back, since your scale is much more similar to that they're showing, you'll be able to recognize it much better as to which graph it is, right? Clearly it's this one. So how do we use the model to estimate the number of employees at the company in 2014? Well, that part is actually easy because T represents the number of years since 2010. For 2014, T would be 4, right? T would be 2014 minus 2010, which is 4. So all we have to do is replace in this equation, right? We're going to replace T with 4. So let's go ahead and work that out. Here we go. So now we're just going to do negative 29 times 4 plus 589, and notice we get 473. Now be very careful when you want to type it in here. If you just put 473, you're not going to get the right answer. Now if they had a box followed by 1000, you know what I mean, then you could put 473. But since they don't, you have to give the actual number, right? And remember that n is in thousands. So when you get 473, you're not actually saying 473 employees. You're saying 473,000 employees in 2014. So be very careful to answer that properly. All right, that should be enough to get you through this homework. So make sure that you get it done in time and stay safe till our next video.